Hi everybody, in this video we're going to talk about reflections. A reflection is a transformation in which every point in a shape is flipped over the same line. And a transformation just means that we're going to be changing the shape in some way. In this case, we're going to flip it over a line. Okay, so we have 4 points over here, K, I, T, and E. Actually, we have an infinite number of points because in between any 2 points here, each point along the line segment is another point. But we're mostly going to be focusing on these 4 points over here. And let's just say that we wanted to flip this shape over the line y equals -1. So I'll write that on the side over here. Y equals -1. What is the line y equals -1? That means that the y coordinate of every point on that line is equal to -1. So no matter what x is, no matter what the x coordinate is, the y coordinate is -1. So that would be a line that looks like this. Okay, so for example, this is the point -3, -1, right? This is the point 2, -1. So no matter what the x coordinate is, the y coordinate is always -1 along this line. So this is the line y equals -1. And what we're going to do is we're going to reflect this trapezoid over this line. Okay, so how do we do that? Well, it's actually pretty simple. I don't know why I want to use green, but I just feel like using green. So we're going to ask ourselves, well, how far is each point from that line? And then we're just going to draw the image of that point that same distance on the other side of the line. So for example, the point K here is 2 spaces away from the line. So we're just going to draw starting from here, we're going to draw 2 spaces on the other side of the line, 1, 2, and then this would be the image of K, which we'll call K prime, okay? We're just going to do that same thing for all of these. So this point over here is 1, 2, 3, 4 spaces away from the line. So we'll just do 4 spaces on the other side of the line. 1, 2, 3, 4, and that brings us over here. And since this was called I, we'll call the image of it I prime, and we'll just keep going like that. So 1, 2, 3, 1, 2, 3. We'll call that T prime. And this point over here, which is exactly on the line, that's 0 spaces away from the line. So the image of E, of point E over here, should also be 0 spaces away from the line. So the image of E is going to actually be in the exact same spot that E is. Okay, so we'll call that exact same point E prime. All right, and now what we're going to do is we're just going to play connect the dots here. So you can see that the image that we got is just the mirror image of the original shape. It's as if this shape was looking into a mirror. If the mirror was the line y equals -1, if this shape was looking into that mirror, then this is what the shape would see. Just like when you look into a mirror, you see yourself staring back at you, right? So when we do a reflection, then we sort of get the mirror image of the original shape. All right? Okay, now well, let me just write the coordinates over here. So the coordinate of the image, K prime, is -2, -2, -3. So let's just write them all down. I prime was at 0, -5. T prime was at 3, -4. Remember, we always do the x-coordinate first and then the y-coordinate. So the x-coordinate is 3 and the y-coordinate is -4. And E prime is at 4, -1. Okay, so that's that. Now let's continue reading over here. When a reflection occurs, the lengths of all line segments remain the same, the magnitudes of all angles remain the same, and the line segments which were parallel before remain parallel. So let's take this one step at a time. The lengths of all line segments remain the same. So you can see that the length from K to I is exactly the same length as the length from K prime to I prime. Okay, and the length from, just for example, from T to E is the same as the length from T prime to E prime. So the lengths of the line segments have not changed, going from the original shape to the image. So the original shape is what we had in pink here, and the blue shape is the image of that shape after the reflection. All right. Also, the angles have not changed. So if this is approximately, let's say, 110 degrees, then this would also be 110 degrees over here. If this is 70 degrees, then this would also be 70 degrees. I'm just eyeballing it now. I don't have a protractor with me. Let's say if this is 130 degrees approximately, then the angle by T prime would also be 130 degrees. And this angle looks to be about 50 degrees, then this angle would also be 50 degrees. Okay, so the lengths, the magnitudes of the angles have not changed. And finally, the line segments, which were parallel before, remain parallel. So in this example, the line segment from I to T was parallel to the line segment from K to E, and the line segment from I prime to T prime is also parallel with the line segment from K prime to E prime. Okay, so lines which were parallel before are still parallel in the image. All right. Now I just want to show you, we could actually draw a line going straight through the shape itself. That's also okay. Just do a quick example of what that would look like. So for example, what if I were to reflect this shape over the line x equals 1. So this is the line x equals 1. Okay, every point on this line has an x-coordinate of 1, no matter what the y-coordinate is. So if we just do a quick reflection over here, let's see, 1, 1. So that would be our new I prime. 1, 2, 1, 2. That would be our new T prime. 1, 2, 3. 1, 2, 3. That would be our new K prime. And 1, 2, 3. 1, 2, 3. That would be our new E prime. And let's play connect the dots here. Let me switch colors just so I think it'll make it a little bit easier to see. Did I do that right? Yeah. Okay, so I'm just going to, you know what? I'm just going to erase all these green lines that I have here just to make this easier to see. After I draw the reflection, I don't really need those lines anymore. So again, you can see that the image, which I drew in blue, it's like a mirror image of the original shape, which was drawn in pink here, except this time, since the line went right through the original shape, the its image is overlapping with the original image, but it's still a reflection. It's still sort of like what this pink shape would see in the mirror if, I don't know, I guess if the mirror was on top of it. So anyway, it's still the mirror image, but it's overlapping with the original shape because this line went right through the original shape. Okay, so moving along here, I'm just going to erase all of this now and talk about what happens if we do a reflection over the x-axis, over the y-axis, over the line y equals x, and over the line y equals negative x. Okay, and I'm not going to do a whole shape. I'm just going to do one point at a time. Okay, so you know what? I won't even need this anymore. Okay, so a reflection over the x-axis. So here's the x-axis right over here. That would bring a point with coordinates a, b to a point with coordinates a, negative b. So for example, if I have the point, let's say, 4, 2, and I reflect that over the x-axis, so here's the x-axis over here, the reflection would be, let's count, 1, 2, and then on the other side, 1, 2. You can see that this is the point for negative 2. So the x-coordinate stayed the same, so I called it A over here, it's still A, but the b-coordinate, which was 2 originally, I should say the y-coordinate, which originally was 2, is now, b went from negative b, 2 went to negative 2, okay? And by the way, I could have started, this won't always end up being a negative number. So for example, what if I had started with the point negative 3, negative 1? And then I reflect that over the x-axis. So 1, 1. So this would be the image of that point. So if I just call this point, I don't know, I'll just pick the letter z, then this would be z prime. So the original coordinates were negative 3, negative 1. The coordinates of the image z prime are negative 3, positive 1. So this doesn't mean that the x-coordinate must be positive. Here you can see that the x-coordinate in both cases was negative. This just means that whatever the x-coordinate was, it's going to stay the same over here. And then this means going from b to negative b, or b to the opposite of b, just means that basically we're multiplying what the original y-coordinate was by negative 1. So if my original y-coordinate was negative 1, then I multiply negative 1 by negative 1 and I get positive 1. So this is the opposite of this. So if I reflect over the x-axis, then the x-coordinate is going to stay the same, but the y-coordinate is going to be the opposite of what it was originally. If it was positive before, it'll be negative in the image. If it was negative before, it'll be positive in the image. Now, what if I were to reflect something over the y-axis? Let's take the same point over here, but reflect it over the y-axis now. So let's count 1, 2, 3, and then on the other side, 1, 2, 3. So this would be the image here. Now this is z prime. And what is that? That is 3, negative 1. So here you can see that the y-coordinate has remained the same. The y-coordinate of the original point z was negative 1. The y-coordinate of the image, z prime, is also negative 1. So that's why I wrote over here, whatever the y-coordinate is doesn't change. It there went b, right? But whatever I had in the as the x-coordinate, I'll get the opposite. So my original x-coordinate was -3. Now the x-coordinate in the image is +3. So that's why over here I wrote A, and over here I wrote the opposite of A. Again, that doesn't necessarily mean that the image is going to be a negative number. You can see here I got a positive number, but it was the opposite of what I had originally. The opposite of -3 is positive. Okay? Now, what if I were to reflect something over the line y equals x? Well, what does that line look like? That line looks like this. Okay? This is the line y equals x. And that should make sense because you can see every point on this line, the x-coordinate is equal to the y-coordinate. So for example, this is the point 2, 2, right? This is the point -4, -4. No matter what point I pick on this line, the y-coordinate over here is always equal to the x-coordinate, hence y equals x. Or if you remember just from y-intercept, slope-intercept form, another way of writing this is y equals 1x plus 0, right? So x is the same as 1x. 1x is the same as 1x plus nothing, right? And 1 is the same as 1 over 1. So if you want to get into slope-intercept form, which we did earlier in the year, the y-intercept of this line is at 0, 0. You can see right here, it crosses the y-axis at 0, 0. And then if I start here and then to get another point, the rise is 1, the run is 1. So I could go up 1 and then over 1 to get another point here, right? And then I could just draw a line through these points, and you can see that it's the exact same line that I drew earlier, even though Okay, so anyway, this is the line all that's really important here is that this is the line y equals x. Now, what happens if I were to take a point and reflect it over this line over here? Well, now I'm just going to do diagonal units. So 1 1/2, and then I'll go 1 1/2 on the other side. Okay? Really would have been easier for me to count a half and then 1. Anyway, this is the same as this, right? Okay, so if this is, I don't know, let's just call it A, then this would be A prime. So if this was at 1, 4, then A prime, where's A prime? A prime is at 4, 1, right? So what happens here? It went from, what did I write over here? AB goes to BA. What do I mean by that? I mean that whatever the x-coordinate was in the original point, that's going to be the y-coordinate of the image. Okay, remember, whatever number comes first is the x-coordinate, and whatever number comes second is the y-coordinate. So here A came first, so that was the x-coordinate over here. But here, A is in the second spot over here, which means that it's the y-coordinate of the image. And you can see what happened over here. Originally, the x-coordinate was 1, but over here, the y-coordinate is 1. Okay, and it's the same thing here with B. Whatever the y-coordinate was originally, that's going to be the x-coordinate in the image. So here, originally, the y-coordinate was 4. In the image, the x-coordinate was 4. Okay, so it went from 1, 4 to 4, 1. And again, this doesn't mean, just the fact that I didn't write any negative numbers here, or I didn't write any negative signs, I should say, that doesn't necessarily mean that it doesn't work if you have a negative number there. So for example, what if I had started with the point -3, -2, half, and then a half on the other side. The image of that would be, what is this point? -2, -3. Okay, so you can see what used to be the x-coordinate is now the y-coordinate, and what used to be the y-coordinate is now the x-coordinate. Now, what if I were to reflect, moving on now, what if I were to reflect over the line y equals -x? I just panicked for a second and making sure that I am recording. That's happened before where I basically talked to myself for 15 minutes and then I realized I wasn't recording. Okay, but I'm recording here. All right. Anyway, sorry about that. Okay, so what if I were to reflect over the line y equals -x? Okay, that line looks like this. Okay, you can prove to yourself that it looks like that if we, that looked really bad, but anyway, you get the idea. You could write y equals -x in slope-intercept form. That would be y equals -1x plus 0, and you could put that over 1, and then you could figure out that this is the line that you get. Or you could just say to yourself, well, y equals -x, that just means that the y-coordinate of any point on this line is the opposite of whatever the x-coordinate is. So, for example, over here, we have the point 3, -3, and you can see that the y-coordinate is the opposite of the x-coordinate. The x-coordinate is 3, the y-coordinate is -3. Over here, let's just pick this point over here. What point is it? That's the point, messed up there. That's the point -4, 4, right? So the x-coordinate is -4, and then the y-coordinate is the opposite of that. It's +4. If I were to plug -4 in here, now we get y equals the opposite of -4, which is +4. Okay, so that's a little bit of a tangent there. I just want you to see that this is the line y equals -x. And then what happens if we were to take a point and reflect it over this line? Well, we would go from AB to -B, or the opposite of B and then the opposite of A. So for example, if I have, let's do it with one positive and one negative. How about that? So let's pick this point over here, -4, 1. Here's my original point, -4, 1. And let's reflect it over this line over here. So 1.5 again. Okay, that's sort of like what I did a couple examples ago. And then a half and then 1. So this is the same as this, the distance. Okay, what point is this? That is -1, 4. Okay, and you can see that what was the x-coordinate of our original number? The x-coordinate was -4, and you can see that whatever the x-coordinate was in the original point, that the opposite of that is going to be the y-coordinate of the image. So the opposite of -4 is +4, and you can see that, yeah, the y-coordinate of this image point over here is +4. Okay, and let's see what happens to the y-coordinate of the original point. Well, whatever the y-coordinate of the original point is, the opposite of that is going to be the x-coordinate of the image. Okay, so you can see here I wrote B, and here I wrote the opposite of B. And here the B was in the y-coordinate spot, right? Here it's in the first spot, which is where we put the x-coordinate. So let's see if that's actually what happened. So here my y coordinate was 1. The opposite of 1 is -1. And so -1 should be the x coordinate of the image, which you can see that it is over here. The x coordinate of the image is -1. Okay. And you could experiment with some points of your own, and you can see that always what happens when you reflect over this line here, the line y equals -x, is that the x coordinate of the original point, the opposite of it becomes the y coordinate of the image, and the opposite of the y coordinate of the original point becomes the x coordinate of the image. That's hard to say, okay, but that's what it is. I hope I said that right. So anyway, that's that, and have a great day.